Hi, in this video we're going to write a few more example Karel programs and talk about how to test your programs in Karel. So the first program we're going to write is one that moves a stack of balls one spot over to the right. So we'll start in the world on the left. We want to end up in the world on the right. So let's go into our editor and write this program. So here you can see Karel is in the bottom left corner and there's a stack of 3 tennis balls one spot in front of him. We want to move that stack one spot to the right of where it is currently. However, we can't depend on the fact that there are only 3 balls there. There could be 100, there could be 5, there could be 7. We want to solve this problem generally. We know that that stack will be in this specific position, but we don't know how many balls are in this stack. So we're going to need to use the control structures that we've learned about to solve this problem. Since we don't know how many times we need to do it, this lets us know that we're probably going to want to use a while loop. So first we'll move to the stack. And then while there are still balls present, well, what we want to do is we want to move one ball. Now, we haven't yet written the function move one ball, but if that function existed and did what we want, we would have solved the problem. So let's see if we can write the function that would move one ball one spot to the right. So function move one ball. This function takes one ball from the pile and moves it one spot to the right, and then returns Karel to his previous position. So what we need to do to move one ball is take a ball, and then what we want to do is we want to move over. So we'll move, and we'll put down that ball. Well, now we need to return back to our previous position. So we'll turn around, we'll move, and then we'll turn around. So before we run it with the while loop, let's just see what happens if we make only one call to move one ball. So it picks up a ball, moves, and then returns us back to where we are. And we see if we repeat that, as long as there are still balls present, we'll have solved the problem. So it moves the first ball, then the second ball, then the third ball, and there you go. So it would be a problem if we specifically hard-coded in the commands to only solve the problem for 3 tennis balls. However, we can see if we open up a new world, one that has 7 tennis balls, our solution will still work. This is because we've used our control structures, in this case the while loop, to help us solve this problem more generally. The next problem we're going to look at is one that has Karel climb up a world. There are 7 rows that Karel needs to go up, and there's one slit in each row that he can fit through. However, we don't know how wide the world is. We can't depend on the number of columns in this world. So we need to come up with a good general solution here. So what we want to do is first, let's see if we can just move up one row, and then we'll try and do it for all the rows. So we'll write a function called move up. So Karel will start at the left side of a row, keep moving across the row until there is open spot, then go through the slot and return to the start of the row. So let's see if we can do that. Well, we need to keep moving as long as the left is blocked. So we'll say while left is blocked, move. Remember here, this is a condition, so we need the open parentheses, close parentheses. So let's just see what this does so far. So this moves Carol to the open spot. Well, now we want to turn left, move through it, turn left again. We'll run this. So at this point, we want to move Carol to the wall. So using good naming conventions, we'll write move to wall. However, that function doesn't exist yet, so we need to write it. So we'll write function move to wall. Well, how do we move to a wall? Well, while the front is clear, we move. So let's reset and see what this does. Okay, the final thing we need to do is turn around. As you can see, as I'm writing this program, I'm testing after small changes. This makes it much easier to write your programs and figure out what they're doing. At this point, we've successfully been able to move up one row. And to repeat this 7 times, which is a fixed number of times, we can use the for loop. So we write for var I equals 0, I is less than 7, I plus plus. And the thing that we want to do 7 times is move up. So let's reset the world and see what happens. All right, there we go. We've solved the problem. And if we try testing on another world, one with only 4 columns, we'll see that our program is general and still works. So the main takeaways here are, as you're writing your program, make sure to test as you make small incremental changes. And also make sure to try your program on different worlds and solve the problem generally using our control structures.